In these last few videos in our Unit 4, we're going to be starting that conversation over polar equations. So to begin that, we're going to talk about complex numbers. A complex number is written A plus BI, where A is our real part and B is our imaginary part, or BI is the imaginary part. We graph complex numbers on a complex grid, where the horizontal axis is our real axis and our vertical axis is our imaginary axis. So we're going to plot basically ordered pairs just like we would with our Cartesian coordinate system, but using the real part and the imaginary part as that horizontal coordinate and vertical coordinate respectively. So graphing a complex number, like graphing a vector 3 plus 2i, our real part is 3, so we're going to go 3 on that horizontal axis, and our imaginary part is 2, so we're going to go up 2 on the imaginary axis, and then that creates that vector. -3 minus 2i, since both of those coefficients are negative, this is going to be in our fourth quadrant. Again, that horizontal axis is our real axis, the vertical axis is our imaginary axis, so we're going to go left 3, down 2. Six minus 2i plus -4 plus 3i. When we're adding these complex numbers, we're just going to combine like parts. So we're going to combine our real parts, which gives us 6 minus 4, or 2. And the -2i minus 3i is minus 5i. Since our real part is positive, the imaginary part is negative. This puts us in the fourth quadrant. And I just realized in that last example, I'm not sure if I said the third quadrant, but example B, when both parts, the real and the imaginary part, are negative, then it's in the third quadrant. I feel like I might have said fourth quadrant. All right, so C, we're going to be in the fourth quadrant. So go right 2 and then down 5 to graph that complex number. Now let's look at relating complex numbers to polar or trigonometric forms to rectangular forms. So the polar form of a complex number is r times cosine theta plus I sine theta. We abbreviate this r-CIS theta. That rectangular form is that x plus yi, or just that a plus bi. That's our rectangular form. And some helpful relationships that we are going to utilize is that x is equal to r times cosine theta, which this is derived from one of those very early rules we learned about cosine theta, and that was that cosine theta is equal to x over r. So all we've done for this relationship is solved for x. Similarly, y is equal to r sine theta, which is a derivative or a different version, a manipulated version of sine theta, is equal to y over r. And then we also have that x squared plus y squared equals r squared, and this is our Pythagorean theorem. Convert the complex number from polar form to rectangular form. So that's that a plus bi form that we want to get to. To do this, we're going to start simplifying these trigonometric function values. So in our first example, 2 times cosine 300 plus I sine of 300, we want to figure out what cosine of 300 degrees and what sine of 300 degrees equals. So I'm going to start setting up my graph for 300 degrees. 300 degrees, that's going to be in our fourth quadrant. Setting up our reference angle of 60 degrees. If our reference angle is 60 degrees, that means our horizontal or x value is going to be 1/2. And our y value, that vertical leg, is going to be square root of 3/2. But because we're in the fourth quadrant, that y coordinate is going to be negative. So going back to the problem, 2 times cosine of 300 degrees is 1/2 plus I times sine of 300 degrees, which is negative square root of 3/2. And now we're going to distribute the 2. So 2 times 1/2 is 1. And then 2 times I times negative square root of 3/2 is going to be minus square root of 3 times I. CIS 90 degrees. So this is 10 times cosine of 90 degrees plus I sine of 90 degrees. And a quick sketch of 90 degrees, that's our positive y-axis. That ordered pair is 0, 1. So 10 times cosine of 90 degrees is 0, plus I times sine of 90 degrees is 1. Distributing the 10, we get 0 plus 10i. Now, depending on the platform that you're using, the requirements of your instructor, the textbook, sometimes we will simplify this to 10i, or sometimes we will leave it as 0 plus 10i, illustrating both the real and the imaginary part of this. Three times cosine of 250 degrees plus I sine of 250 degrees. 250 degrees is going to be in the third quadrant. And that makes our reference angle, if we take 250 and subtract 180, our reference angle theta prime is going to be 70 degrees. Since 70 degrees is not an angle on our unit circle, we're going to have to use our calculator for this. So if I evaluate cosine of 250 degrees, that gives me negative 0.342 plus I times sine of 250 degrees. Sine of 250 degrees is negative 0.940. And if I distribute that 3 times negative 0.342 is negative 1.026 minus 3 times negative 0.940 is negative 2.82i. So that was going from polar form to rectangular form. In this next example, we're going to go from rectangular form to polar form. Negative 3 minus 3i square root of 3. So I'm going to rewrite this just so I can see my real and imaginary parts a little bit more clearly. So this is the same as negative 3 minus 3 square root of 3i. Now, these different variations, the order where that I is placed, the way the problem is set up with that I in the middle is pretty common, mainly because we don't like to have values, factors after a radical. It becomes very, very confusing whether or not it's included in the radical or not. So that's why we put it out front to very clearly show that there's nothing else, there's nothing in the radical or outside the radical past it. So our real part is negative 3. I'm going to go ahead and sketch this graph. So we're going to go 3 to the left on that real axis and then down 3 square root of 3 on the imaginary axis, which 3 square root of 3 is like 5 point something, I'm pretty sure. Which isn't really necessary, but it does help us give a nice visual there. Yeah, it's like 5.2. So just to help make our picture as accurate as possible. So in order to write this in polar form, that r CIS theta, we need the radius, which is the length of that hypotenuse, and we need that angle theta, theta being measured from that positive x-axis counterclockwise to that terminal side. So let's solve for r. R squared is x squared plus y squared, or that real part plus the imaginary part squared. So -3 squared plus -3 square root of 3 squared. -3 squared is 9. -3 square root of 3 squared is going to be 9 times 3, or 27, which is 36. So r is equal to 6. Now, I'm going to use this right triangle. So I'm going to call this angle theta prime, because it's not really theta, right? That's just part of our angle that we're going to use in our polar form, but that theta prime is that reference angle. So I'm going to use tangent of theta prime, which is equal to opposite over adjacent. So -3 square root of 3 over 3, -3. Simplifying this, tangent of theta prime is equal to the square root of 3. And then I can use inverse tangent of the square root of 3 to find that theta prime is 60 degrees. Since our reference angle is 60 degrees, then that means the angle for our polar coordinate theta is going to be 180 plus 60 degrees. So this rectangular form, 3 minus 3i squared root of 3, in polar form is your radius, 6, CIS 240 degrees, or 6 times cosine of 240 degrees plus I sine of 240 degrees. Our next example, that rectangular form is -5i. So I'm going to write this as 0 minus 5i. And now to graph this, my real part is 0 and my imaginary part is -5. So that puts us at this point on our negative vertical axis, or that negative imaginary axis. From here, we can clearly see that the radius is 5. And we know that since it's a quadrantal angle, that this angle theta is 270 degrees. So our polar form is 5 CIS 270 degrees, or 5 times cosine 270 degrees plus I sine of 270 degrees.